I will attempt to explore the major existential threats to humanity that we face in our near to very distant future, using a timescale stretching from the present day to 100 trillion years ahead in an effort to come up with practical solutions and contingency plans to enable the survival of the human race and other life forms for as long as is possible. In our immediate future, we face three major threats to extinction. A contagious aggressive virus like the Spanish flu of 1918 could decimate the world population rapidly. However, with rapidly developed and administered vaccines, good sanitary practices, and antiviral drugs to slow viral replication to undetectable levels, it's conceivable that humanity can persist in the face of epidemics, though of course the first world is far more equipped to deal with this than poorer nations. The threat from nuclear disaster could hopefully be avoided with diplomacy. Sanctions on aggressive nuclear nations can be used as a deterrent, and if it comes to it, strategic attacks on vulnerabilities to deter an attack from an aggressor or eliminate the threat entirely are options nuclear nations must always be ready for. Nuclear shelters could allow people to survive attacks also. If the shelter withstands the initial blast, in most cases, you'd have to remain in the shelter for 28 days approximately. 99% of the radiation emitted in the fallout, radioactive dust, will have decayed after that time and you can then leave the shelter. Using food stockpiling, growing food with reduced sunlight, some of the hardiest and simplest to grow include potatoes, cabbage, and beetroot, which could be grown once you remove the fallout-covered topsoil. As well as relying on famine food in desperate situations, it's conceivable that well-prepared humans can survive a nuclear winter also. The threat from AI or grey goo, mini machines that could replicate, consume, and decimate ecosystems and resources, is not from them turning rogue and attempting to destroy us. It's from them having autonomy and goals that differ from our own. For example, if a super-intelligent system is tasked with an ambitious geoengineering project, it might wreak havoc with our ecosystem as a side effect, and view human attempts to stop it as a threat to mitigate. Aligning goals of AI with our own is an important safety engineering feature needed to be deployed before beta releases of autonomous AI. The hot topic of today is the potential threat from catastrophic climate change in the near future. But is it truly the existential threat that activists claim? For the purpose of this video, let's assume that it is and see what solutions we can come up with to combat it. Apart from reducing emissions in an attempt to mitigate climate change, theoretically we could use climate engineering to modify the amount of sunlight that actually reaches the Earth's surface. By introducing sulfate aerosols in the stratosphere to reflect sunlight away, thus reducing global warming. Using a balloon tethered to a ship, you could elevate and pump these aerosols into the upper atmosphere to accomplish this particular goal. Another partial solution is perhaps ocean fertilization, which involves the spreading of nutrients such as iron, urea, and phosphorus in the upper ocean, which stimulates plankton blooms that act as a marine food source and which has the added benefit of reducing CO2 levels to combat excessive global warming. Cultivating more forests is another option. But these solutions are quite large scale. On a smaller scale, adapting our diets, homes, and lives to a changing environment is perhaps the best solution. Buildings can be constructed with materials and paints that reflect excessive sunlight. Homes and greenhouses can be engineered to be climate controlled, and people living on disappearing coastal areas can build levees to regulate water levels or relocate inland where possible. Most asteroids are discovered by a camera on a telescope with a wide field of view. The NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS for short, in Hawaii can detect the larger of these asteroids that could potentially strike Earth years in advance. Though for smaller asteroids, it will detect them years too late to implement potential deflection. However, it could provide the days or weeks of warning needed to evacuate and otherwise prepare a target area. For example, most of the damage and injuries caused by the 20-meter meteor impact in Russia in 2013, the Chelyabinsk event, were from window glass broken by its shockwave. With even a few hours' notice, warning those losses and injuries could have been much reduced by actions as simple as propping all windows open before the impact and staying away from them. If we want to get serious about preventing a major impact and don't just want to take our chances on luck alone, we would need a dedicated space-based system of cameras for detection and ground-to-space rockets on standby from the military, as well as space-based lasers to divert and disintegrate incoming asteroids. Supervolcanoes, like those found in Yellowstone National Park, if they ever erupt again, threaten to spew ash for thousands of miles, damaging buildings through collapsed roofs, smothering crops, and shutting down power plants. Though the risk of this happening is not very high in the immediate future, how could we potentially survive the threat from such an eruption? Firstly, we would likely get years if not decades or centuries of warning prior to a super eruption, and therefore could prepare well in advance. Preparedness for ashfalls could involve sealing buildings, protecting infrastructure and homes, and storing sufficient supplies of food and water to last until the ash falls over and cleanup can begin. Dust masks can be worn to reduce inhalation of ash and mitigate against any respiratory health effects, and goggles can be worn to protect against eye irritation. Gamma ray bursts, GRBs, are extremely energetic explosions in space. They are the brightest electromagnetic events known to occur in the universe. The intense radiation of most observed GRBs is thought to be released during a supernova or superluminous supernova as a high-mass star implodes to form a neutron star or black hole, and can last from 10 milliseconds to several hours. If we on Earth happen to be pointed on the wrong end of the barrel of a GRB at a relatively close proximity of a few light years away, would we all be doomed? Not quite. Earth's atmosphere is very effective at absorbing high-energy electromagnetic radiation such as X-rays and gamma rays, so these types of radiation would not reach any dangerous levels at the surface during the burst event itself. The greatest threat from a GRB pointed at Earth from a relatively close distance is from UV rays following damage to the ozone layer. Adapting our clothing and architecture to prevent excessive UV damage is the main solution to this particular threat. Similar threats from acid rain due to GRBs affecting the chemistry of our atmosphere can be solved with similar means. In a billion years, as the sun increases its brightness, the increased luminosity will cause the planet to heat up and the oceans to boil, rendering much of the planet, at least on the surface, uninhabitable. Perhaps we could use space-based mirrors and even gigantic sunshades to control the amount of light from the sun that reaches Earth. But eventually, in about 5 billion years, the sun will grow so large as a red giant that it will likely swallow Earth, so inevitably we'll have to migrate away from Earth to life-sustaining spaceships and colonies on other moons and planets. When eventually all stars in the universe cease to fuse and produce light, and there are no new solar systems that futuristic life forms could migrate to in order to extract energy from, does this imply that life is ultimately doomed? Well, if possible, an advanced civilization might hypothetically attempt to escape to a new universe via a wormhole. Though there is no guarantee that this is even physically possible, it would require matter with negative mass to prevent wormhole collapse. Despite being inconsistent with the expected behavior of normal matter, negative mass is mathematically consistent and introduces no violation of conservation of momentum or energy. If no escape to another universe is possible, death may just be inevitable. Though if biological or artificial life could hypothetically escape the death of our own universe, it would have to continually hop to different universes as they eventually die in order to remain living indefinitely. It would therefore require an infinite traversable multiverse with universes conducive to life for species to gain true immortality. And even if this is not a violation of the laws of physics, and it may well be, it would require civilizations with godlike gargantuan amounts of energy, and the ability to manipulate the physics of the universes that they traverse to ensure that they are hospitable to life. Otherwise, you'd be flying in blind to a new unknown universe, which may not be habitable. All of this, needless to say, would be extremely difficult to accomplish, if not impossible, and therefore may remain forever beyond the limits of even a super-intelligent civilization. As I have attempted to illustrate, we can use medicine, engineering, and technology to either solve most if not all of these problems, or to create new ones for ourselves, like pollution, senseless violence, food shortages, and overpopulation. Well-meaning activists often organize protests in an attempt to motivate governments to take action on global threats, but I tend to steer away from collective solutions to these problems. Relying on support throughout the globe to tackle these threats is, in my opinion, not very practical. Threats are not equally shared throughout the globe, and therefore there is, in my opinion, no collective solutions to these threats. The solutions will need to come from engineers acting out of our own rational rather than panicked survival instincts, with foresight of the existential threats to our survival. Of course, circumstances, misfortune, lack of resources, and the complexity of these issues may render some or all of these proposed solutions untenable, which may mean that the rise and fall of humanity, and perhaps all life in the universe, will ultimately end in tragedy. A scenario we can treat with dark humor as we're led to the gallows. But I think we have the responsibility to extend the light of life and consciousness in an otherwise inanimate universe for as long as is humanly possible.